Okay, so let's begin the topic of discussion today. So I've just come up with this capsule session. Probably you people might have attended last week's session. So today I thought of coming up with the Docker topic because that's something that is widely used in the market today. So we need to have the base essential knowledge on the Docker. So that's why I thought of coming up with this topic. Probably let's see how far that we can complete today. If not, part 2 will be taken up next week as well. So like which not I mean if even if it's not possible on every Saturday because it depends on my free time. I'm trying to come up with these free sessions. It's completely free, no commercial trainings I'm doing right now. So it's all completely free. So during my free time, I'm trying to engage with you people so that I'm happy to share my knowledge to you all. Okay, so that's the main intention of this capsule sessions. So the thing is, yeah. So today the topic is on Docker. So I'm not sure how many of them are aware of Docker, or you might be working with Docker as well before. But even in spite of that, let's understand the base fundamentals of Docker so that it can help you a lot in your career. Okay, so without a due delay, let's step into that. I have a small application here. Last week I used an application called Sports Store, which is a Spring Boot application. The same application, we will use it for today's demonstration as well. Okay, so technically we have an application here, which is a Spring Boot application, right? And this Spring Boot application can be archived into a specific artifact. So it can be a war or it can be a jar file. So you people, if you're new to Java, then probably you need to understand this artifacts. These are called as artifacts. So once we create the specific uh, artifact, either in the form of a var or a jar, we are able to deploy that application or deploy that artifact into the specific environment. So it could be a production environment or it could be a testing environment. So it depends on, there are multiple environments we have, right? So, but technically speaking, Spring Boot is by defaulted with jar, right? So default artifact that you produce out of Spring Boot is jar. Var is a web archive file, right? Web archive, and jar is a Java archive. So Java archive means it is a standalone web application. Okay, so that is what it means actually. So um, standalone archive, standalone web archive. Why? Because it has a embedded Tomcat server inside the jar itself. So embedded Tomcat. So we can either deploy them into an external Tomcat or we can make use of the embedded Tomcat itself. But jar cannot be deployed in external Tomcat. So that's why we go for var. So var archives are distributable standard of archive. Okay, so it's more of a distributed application, we can call it as, right? So it's not a standalone. It's going to be an archive of distributed archive. So we can able to deploy the var standard into an external Tomcat. External Tomcat. So Spring Boot is one way of creating a Spring based application. It's much easier when compared to the traditional Spring framework usage. So we can quickly develop the application. Anyways, I'm not going more detail into it. I'm just giving you a base. Okay, so we already have the Spring application and we can query the data. It has an in-memory database as well. Okay, we use a H2 in-memory database. Okay, so through this H2 in-memory database, we can store data and retrieve data quickly. And also we have done a bit of configurations in this, uh, I mean, in the application.properties. So we have an application -Dave as well. So there are two configurations. So right now I'm just going to drop it into the application.properties. So this piece of configuration, what you're seeing here, I hope it's visible, right? So you can see that this is a configuration that we have done for in-memory database. Okay, to connect to the H2 database, I've given some set of settings in the application.properties file. Fine. So what this application will do, this application will help us in getting the data from the database. Okay, you can query the data like product details and so on. So for that, we have a specific controller created here. So this controller will help us in communicating with the service layer, and the service layer will in turn communicate with the DAO, and the DAO will in turn communicate with the H2 database and pull the data. So what is the endpoint that we have is products. So this products will help us in fetching all the product details that are stored in the database. So we do have the data.sql for this, where the actual query is residing. At the time of launching this application, this query will get executed. So you can see I have given some set of insert records and as well as the create tables. Okay, so this is a base information. I'm not going more deep into it. So there is a dependency challenge. So let us resolve this. Maven update project. Update. So these are Maven dependencies that we are using. So let's come back to this application. Now, what we have to understand here is traditionally, last week we deployed this application into AWS environment, right? Probably what we did there was we spinned up an Linux server, okay, Linux server, and in that Linux server, we installed all the required softwares. Like for example, we installed Java, okay, we installed Maven, right? So we also used Git to pull the repository, the source code from the repository. So we installed all these softwares, right? But the thing is, we use the Linux server, okay? And for one application, we are using this Java, Maven, and Git, and so on. So what happens is we are manually involved in installing all these softwares, right? But when we jump into Docker, okay, Docker will have everything pre-installed, right? So all these softwares we can create a Docker image which carries all these software readily available in a standard of image. So Docker is a brand name. Okay, Docker is a brand name, but the concept that the Docker uses in is called as containerization. Okay, containerization. Containers, we call it as containers. Okay, you can run a container. We can say you can run your application on top of a container. Okay, so what does it mean when you can run an application on top of the container? It means it is actually a containerization concept where you are using Docker in it. Okay, there are different other containerization tools are also available, but Docker is much familiar and it's more of open source, but it is also having a commercial standards in it. So containerization is the concept that we are going to understand today. Okay, so how do we implement this? First, you need to have some basics to understand. So I'll just take you to that. Today, even we are going to use the AWS services to create the EC2 instance and so on. So uh, there is a specific GitHub resource which talks about the Docker more in detail. Okay, so here you can have some base understanding. So what I wanted to show you here is containers versus virtual machine. Before, what we used to do was in our in a specific data center, let's say you have a application server, physical server, where it is going to have some multiple virtual machines. Okay, virtual machines will be used to deploy applications. We will be having multiple virtual machines, and in each virtual machine, we'll be launching the applications. Similar application instance will be launched in multiple virtual machines. So virtual machines are heavy weighted. Okay, it's heavy weighted. Virtual machines are heavy weighted. You spend too much of memory for virtual machine. Let's say, for example, you want to spin up a Ubuntu server, okay, using a virtual machine, then you need to invest some 2 GB of resource, right, for that virtual machine in your host operating system. So your host operating system can be anything. It could be a Linux again, and on top of that Linux, you'll be running multiple virtual machines, and each virtual machines might have a memory consumption of this much, right? If you go for GUI mode, then probably it will increase more even. So it can go to 6 GB or it can go to 8 GB. It depends on what requirement you have on the server. So the sizes are pretty huge, right? So here, if you look at it, we have an host operating system, which is uh, technically a let's say it's a Linux server or it's going to be a Windows server, right? This is physical machine. The server, what we are highlighting here is a physical machine, physical machine. Okay. And on top of the physical machine, we have installed one operating system, and that operating system could be a Linux operating system or Windows operating system, a server-based operating system, and we call it as a host operating system. On top of the host, we will be having hypervisor, which need to be installed to ensure your virtual machines are running. These are guest operating systems. These guest operating systems will utilize the maximum resource, right? So a separate operating system which is running on top of the host operating system, and you will be allocating the RAM size. Let's say, for example, for this guest OS, you will be allocating 3 GB RAM. For this guest operating system, 3 GB RAM. For this guest operating system, let's say 4 GB RAM. From where you will allocate these RAM sizes? From the host server only, right? So in this host server, you'll be having, let's say, 64 GB RAM, right? So when you have 64 GB RAM, you can split that 64 GB RAM and give it to the individual virtual operating system, right? And on top of the guest operating system, you will be carrying the dependencies, the libraries, binary files, and everything, whatever required for that application. Let's say if it's a Java, you need to install Java library. Okay, if it's a Maven, you need to install Maven tool. So all these software application relevant dependencies and binaries and libraries need to be loaded. And on top of that, your actual application will run. This is the traditional way. But if you look at the Docker, what is the main difference between this virtual machine and the Docker is you will not be having the utilizations of memory like how the virtual machine was doing. Here it's going to be pretty simplified. You have a physical server, you'll be having an operating system, and you'll be having a Docker engine. The Docker engine will help us in launching multiple Docker containers, and on top of the Docker containers, you'll be having the binaries and libraries, okay, and your application will be running on top of that. So you can run multiple applications in the same container also. Okay, so this is going to be your container concept where your container interacts with the host operating system. So does it mean that the container doesn't have an operating system? Of course, it will have an operating system, but that's a lightweighted operating system. It's going to be called as a lightweighted operating system, okay, which will not cross more than 250 MB of size. So if you want a Linux operating system, you'll be having just to spend 250 MB of memory consumption. But that OS, the host operating system, will be shared. But here the host operating system is not shared. You have a separate full-blown operating system, full-blown operating system. But if you look at here in this layer, you will not have a full-blown operating system. Containers will share your operating system, okay, and it will also communicate with the host operating system. It's easy to communicate with the host operating system and make use of the services of the host operating system. So it's more of a lightweighted approach, and it's more flexible, okay, and it's more what to say, shippable. Okay, why containers are shippable? Because everything is pre-built, right? Your operating system, your binaries, libraries, everything is there internally, and your application is also going to be there. So everything is pre-built within this the containerization concept itself. So it's pretty easy to ship your application, okay, packaged in a container and distribute it. So let's say I will be using a term called image right now. So the image, what happens is the image will be distributed to different environments. So let's say I have an X person who is working on the application, and the application is going to be packaged into a Docker image, and the image will be published into one specific repository, the image repository, and Y person can pull that image and run the application in their specific environment without a need of installing all the softwares from the first. He or she does not need to work on bringing up a virtual machine up, downloading the virtual machine operating system, the ISO image, and then bringing up the server, installing all the dependencies. Nothing is required because everything is packaged in the image itself, readily shippable. Okay, so that's why they bring that concept called container. If you go for a shipping industry, you will find that the ships are shipping the products in a container only, right? So it's easy to transport. It is easy to transport, so everything is going to be in that container itself. Okay, so refrigerated containers are also there. Refrigerated containers, what it does is, if it's a perishable product, your perishable product can be hold it in that refrigerated container, so that it can withhold for a certain number of period until it reaches the destination, right? So whatever is needed can be there available inside the container itself, and it's easily shippable. Shippable means we can also call it another technical term called portable, right? It's portable, highly portable, it's easily portable compared to your virtual machines, right? And moreover, you will be having multiple containers which can be spinned up in just a matter of minutes. Okay, multiple containers can be spinned up. Okay, and it can contribute in terms of microservices. Today we are talking about microservices, right? So when we go for microservices, containers will contribute a lot of support for building a microservice based application. So you'll be having multiple applications, application A, B, C, D, right? All these applications can be deployed in a separate containers, and each container can communicate to each other to get its request response process happening thoroughly, so that it can give the final response to the user what they wanted, right? So there again, in the microservice world, we bring in the concept of containers, right? Rather than going for a huge heavy weighted virtual machine, we'll be using a lightweighted container. So in order to bring this container setup, we need to go for the Docker. Docker is a containerization tool, right? So it has a Docker engine. Docker engine is the most important tool that we will be having in the entire in the entire ecosystem. Okay, so Docker engine is the heartbeat of a specific containerization concept. Okay, so this engine, through this engine, you'll be able to communicate to the specific operating system. Okay, we also call it as a daemon. We'll be using a term called daemon. We'll get back to that shortly, but I just wanted to explain this diagram first. Okay, we'll come to the state of understanding the concepts more in detail. But before that, let's quickly get into some demonstration so that you will feel the usage of the Docker. Okay, so what is that we need to do is, first we need to spin up one virtual machine. If in case you have any questions, please do let me know on this, so that I'll try to explain at my best. So meanwhile, I'll just sign into the console of my AWS, where we'll spin up a server, a Linux server, like how we did in last week. The same way I'll be doing it here.
Sir,
Skull
without
that,
AWS, Docker is possible in standalone application in Linux.
sorry, can you be a little louder?
Uh, Without AWS, Docker is possible in standalone applications.
Without
Hello?
AWS, you want to do a Dockerization, containerization.
Yes. So,
Yes. Of course you can do it. Okay, of course you can do it. See, this is my Mac operating system. In the Mac operating system itself, we can install Docker. Already Docker is there in my Mac. Okay.
okay.
The reason I'm not using the Mac right now is real time. Okay, when you go to real time, you'll be working only on the Linux based systems. You're getting it? So it's good
Yeah.
that you gains more knowledge on working on top of the Linux, the deployment of
Sir,
applications, everything.
yeah, other
Yeah,
than AWS, we directly deploy to the Linux servers of the Docker.
of course, yes. Of course, you can do it directly in the Linux server itself. So let's say, for example, if I have, anyways, this is a Mac operating system, right? So if in case I want to practice this in my Linux non-AWS environment, you can download the Ubuntu server. Okay, get an ISO image of Ubuntu server. So, so here you can go and get one. I've already downloaded one Ubuntu server here. The reason I'm not using it because I want to use the domain name service, DNS, so that you will be able to access the application. So that's why I'm going for AWS, and it's pretty easy to spin up the server there. Okay, so you can go for manual server installation and download this 1.8 or something, 1.4 GB or something. So this you can download it. You ensure you have your VirtualBox available in your machine. Okay. So through VirtualBox, you can launch this ISO, and inside that you do whatever steps that I'm going to show you right now in the AWS.
Okay, sir.
Okay. So that you
Okay.
have to do. If in case you don't want that Linux, you have Windows machine. Suppose if you're running Windows operating system, you can still go ahead and download Docker for Windows. You have Docker for Windows, and from the Docker desktop, you will be able to do all these steps. But advisably, please don't work Docker on Windows. In real time, 99.99% of the people are not using Windows. They will use only Linux. Okay. So if you have Mac is more or less same as Linux only, right? Its kernel is designed on top of the Unix based only. So it's good to work with Mac also, but please don't work on Windows. But there are certain cases where still Windows also having the Docker support, because there are Windows servers are there. Many clients are using Windows Server and they are using Microsoft products, okay, .NET applications and so on. In that case, you need to have some basic knowledge on working with Windows. But other than that, if it's a Java based application, damn sure that it's going to be built only on top of Linux. Okay. Now, whatever I'm going to show as a demo on the AWS Linux instance, you can do the same step on your local Linux operating system, the one which you might be having it in your laptop, or you might be having a Windows laptop. On top of that, you will have a virtual machine called Linux operating system. On that, you can go ahead and install your Docker also. Is that clear?
Yeah. Yes, sir. Understood.
Okay, thanks. If anyone have any other questions, please do let me know. So meanwhile, let me log in. So if in case you don't have AWS account and you don't want to get into AWS account, create some services, and you don't want to get trapped into the billings, if you feel that way, then better don't use AWS. You better go for creating an local virtual machine, which is of Ubuntu server. Advisable is Ubuntu, or you can go for Fedora. Okay, let me sign in.
Test account is possible, right, with AWS for 1 month.
Hello.
Yeah, I think test account is possible, right, with AWS, free test account.
Actually, voice is low. Once again. Uh, yeah, yeah. Tell me, please. Sorry, you can speak now. You can speak now. Sorry.
Yeah, I was saying AWS free account is possible, right, for 1 month.
Exactly. Exactly. Yeah. Yeah. True. True. That's true. That's true. So that's what I was about to say actually. So we have a free tier, right? 1 year of free tier we have. So you can make use of that 1 year of free tier, and you'll be able to use 750 hours of compute EC2 compute service, which is almost you can use it for 24 hours. One instance only I'm talking about. Okay, so 24 hours per day you will be able to run continuously. But for practicing, I guess you will not use for 24 hours. Whenever needed, you just shut down. Okay, you just shut down the instance and then go ahead and relaunch it whenever needed, so that you will not be build on top of that. So free tier is what which you can use, and I'm also using the same free tier only right now. And you, if you have multiple Gmail accounts or email accounts, every year you can have one account for free. So you don't need to get into any paid mode of billing. Okay, let me get authenticated. Okay. So this is AWS console dashboard. So I step into EC2 service of the AWS, one of the services, EC2 service, which is a compute service. It helps us in launching your uh, instance, the server instance quickly. So you have 30 GB of EBS storage, which you can consume. Okay, elastic block storage, which is tied up uh, to an hard disk like for a particular server. Okay, so let me quickly launch. Uh, I'll be coming up with AWS sessions as well. Okay, so this is just on Docker, so I don't want to spend too much of time on the AWS. Let me go ahead and launch an instance. So you can see all my earlier instances are in stopped state. Okay, or it got terminated, right? Completely it got terminated, stopped. The reason is at that time you don't need to pay for it. Pay for only what you use, right? So we will not end up with any much of a billing cost. But we need to be little disciplined while we are working with cloud. So we need to be more aware that what kind of a services are we working on, how we are going to shut down the services, how we are going to delete the resources so that you will not be occupied with too much of cost. Okay. Absolutely, there are n number of services which is built within the pre-tier itself. So you can easily work on it. So Docker Linux server. Just I'm giving a name for it, and here you can choose the instance that you wanted. Okay, whether it's a I mean AWS Linux instance, or you wanted to have Ubuntu. Okay, even we have Windows instance. Okay, but everything that comes under the free tier, please ensure, while by default it will be taken as a free tier. Okay, the options which you are going to choose will be default with free tier, but if you want to jump to other versions other than the free tier, you can go ahead and choose, and the cost will be accordingly. Let's leave it to the free tier right now. I'm using the Amazon Linux instance itself, and down we have T2 Micro, which is again a free tier. But if needed, if you want to upgrade to some the RAM as 4 GB or stuff, then probably you'll be going for uh, medium. Okay, T2 medium. T2 medium will provide 4 GB of RAM memory. Okay, but T2 micro will only offer 1 GB of memory. For working with Docker, 1 GB of memory is more sufficient. But if in case if you're going to work on DevOps tools, like for example, you want to deploy some Jenkins, you want to have some Sonar Cube, you want to have some Nexus server, the artifact repository, and all those DevOps tools that you want to bring in, then probably you need to go for medium. Okay, the 4 GB memory, because the amount of memory, that 1 GB will not be sufficient for working with all the DevOps tools. Probably in the near future, I'll be coming up with these with those sessions as well. Okay, I plan to come up with DevOps sessions. It will be quite interesting. Okay, it's not like more of a programming there, right? So we'll be working with too much of tools. So understanding them and working will be playing around with those tools will be quite interesting. Anyways, so let's take this T2 micro, and we need a key pair for logging into this particular instance, which is going to be called as a private key and public key. Public key will be associated in the EC2 instance, and the private key will be provided to our user access. So we'll need to download that key and keep it. I already have the key in here. Okay, there are multiple key pairs have been created. So I'm going to make use of the Spring Boot app, which I've created last week. If needed, I can create one and I can download it, but it's already there. Okay, so I don't need to create it again, and open for external access. This instance can be open for SSH communication. Through SSH only you can log into this secured shell. Okay, through secured shell you'll be able to logging into the EC2 instance from anywhere, who anyone anywhere can access. It's an open access, and default is 8 GB of RAM. Okay, so if you want to increase, you can increase. At that time, if it crosses more than 30 GB, then probably you have to pay for it. You can see that the definitions are given here. Okay, in your first year include 750 hours of T2 micro or T3 micro in case T2 micro is not available, and 30 GB of EBS storage, right? And 30 GB of EBS storage is what I said, and 2 million IOPS and 1 GB of snapshots and 100 GB of bandwidth. 100 GB of bandwidth we have. Okay, so we can maximize that. Not a problem. Okay, so let's go ahead and quickly launch this instance. So definitely you don't need to work on AWS. Okay, you can still go ahead and think of having your local virtual machine instance can be spinned up. You don't need to get into AWS at all. But I'm more comfortable with AWS because it's quite easier for us to launch the compute instance quickly. Okay, so here we have Docker Linux server, and the status of that instance is pending. So means we have to wait until it gets successfully launched. So now it's up and running. You can see the status is running. See how fast it is to launch. Even though this is a virtual machine, this is also a virtual machine, but that's been deployed on top of the cloud. That's the only difference. Instead of we having a local instance of virtual machines running in our local host, we are going to run them on the cloud. That's the only difference. So go for grabbing your IP. Okay, so this IP, or you can use your IPv for DNS. So here you can see that we have IPv for DNS name. You can just copy them. Okay, these are public IPs, right? So now let's jump into our terminal and so let's go for print working directory. So I'm inside the EC2 instance. There's a directory called EC2 instance which I've created, and that EC2 instance I have my uh, key pair which is already downloaded and kept ready. Okay, so this is my Spring Boot app PEM file. Okay, the key pair which is already available. Okay, so let's go ahead and use SSH. Hope it's visible to you all. You all can read it, right? Okay. So we have that PEM file here. Okay. So use SSH and you can use your -high and to connect to your EC2 instance. So you need to offer this Spring Boot PEM file. Okay. I means for interactive connectivity. SSH with an interactive mode of connectivity with the Amazon EC2 instance. Now listen carefully. The username for the EC2 instance is EC2-user. Default will be EC2-user at the rate, and then I'm going to drop the domain name which I've copied. Okay, this is the domain name that we have copied. So SSH-i, the PEM file, and the username to log into that particular EC2 instance, and followed with the domain name. So separated with @ symbol. Okay, hit enter. So do you want to continue with this connection? Yes, please proceed. Great. Now listen carefully. Right now I'm not into my Mac operating system. Okay, so I've come out of that, and right now we have this. Here you can see there is a EC2-user is displayed. Okay, so what does it mean is it means that we have logged into the virtual machine which is running on top of the cloud. Okay, so that's what it means. Look at this. The user that we have logged in is EC2 user, right? So inside this machine, we are inside this virtual machine is where we are going to work around. Since it's Mac, I'm using console mode of SSH connectivity. If you are working on Windows, then you can use MobiX term. Okay, there's a tool called MobiX term. You have a freeware, you can download it. It's more UI friendly, and you'll be able to quickly launch through UI to connect to the EC2 instance. So we don't have MobiX term for Mac. So that's a reason I'm going for SSH tool directly available in Mac. Okay, so right now, if I say ls, you can see it's going to have nothing because I'm into the virtual machine of the cloud operating system. Okay, the cloud Linux operating system, which is running up and running. So first thing is, let's jump into root access, administrator access, root user. Right now we are on EC2 user, which will not have a root credential. So we need to log in as a root user. To log in as a root user, we can use sudo command. Okay, su switch user. Su means switch user, hyphen refers to the root. So hit enter. By this way, you'll be shifted to root. You can have a look at here. So from EC2 user, we have jumped into root. So we need root privilege in order to install the softwares in the EC2 Linux system, right? So let's go ahead. Inside this, we can quickly go ahead and um, install the Docker. So we have a tool called yum here. Yum is a package manager. Yum tool is a package manager tool, and this package manager tool can be used for installing your softwares in this EC2 Linux, which is Fedora based. Okay, but we can also launch Ubuntu. If you want Ubuntu, you can go for Ubuntu. At the time, you can use apt command, apt. Okay, apt tool instead of yum package manager. Ubuntu uses apt, wherein Fedora style of Linux family uses yum. So yum package manager. I guess yum is going to be deprecated, and they are going to use something called DNF. So let's use yum install. Just say install. It will have all the software packages in the yum package manager. So it'll go all the way to the yum repository and try to download it. So what do we want to install here is Docker. So yum install Docker. You can see it's installing, and you can see that it is taking almost 67 MB of total download size, and install size will be 280 MB. Means it's going to be extracted later. So let's say yes. So by this way, it starts installing its package. The yum is doing its job. So Docker is getting installed. Great. So now we have successfully installed the Docker. Let's check if the Docker is available. So for that, you can use Docker space hyphen version. Now you can notice that the Docker version is 20.10.13, which got downloaded in this particular EC2 instance. Okay. So what is this tool? How do I check that? So this Docker, when you install the Docker which I'm using right now is a client. It is called as a client, Docker client. Okay, it's a client tool. So when now henceforth you will be using the command called the tool called Docker. Okay, Docker is client tool, Docker client tool who will communicate with daemon. Okay, who will communicate with daemon, that is Docker daemon. Typically, it is called as like Docker engine, right? Docker engine, we are going to communicate. So how do you communicate with the Docker engine? Through Docker client. So what is the tool? Is Docker. How we got this tool? By installing the Docker software. By installing the Docker software, you get the Docker client also installed, and as well as your Docker engine also gets installed. The entire software will get installed in it, right? So for that only we use that command called yum install Docker. That's it. A very simple step in Linux, right? Rather than going for GUI mode of download and then installing, you can just quickly do this way. So now we have this Docker running, but always you don't want this to be running under the root mode, right? You wanted to run this on the user mode, EC2 user itself. You want to run them. So in order to do that, we need to add the user into this Docker group. Okay, So we need to bring the EC2 user to be a part of the Docker group. But how do we know what are all the software groups are available? Okay, so that we can go and check by using the file called cd/etc. Okay, I'm sorry. Instead of cd, I can just say cat. Cat command is used to view the data of the particular file. So etc slash, we can use the group. Okay, etc slash group. Now you can see group is a file, okay, which is available in the etc directory. Okay, so we are getting into the etc directory and opening the group file just for read only purpose. Cat command is used to just read what's there in that file. All these software groups you can see, these are all softwares which are already available, and these softwares are having a specific group. Now you can see in the last there is one Docker. Hope you can see this here, right? There's a Docker group is there already. When it got created, the moment we install the Docker in our Linux operating system, automatically this group will get created. So in this group, you can add the user. There is no user available. Please have a look at it. There is no user right now available, right? So we need to bring that user into this group. So how do we bring that user into the group? We can just say user mod. Okay, the tool called user mod tool, an option called add group -ag caps. Okay, -ag add group user mod add group docker, add the group docker to EC2 user, so that the EC2 user is going to be a part of the Docker group. So I hit enter. So it got added into the Docker group. EC2 user is now assigned to the Docker group. Now you can just run that cat command /etc/. You can just try out with the group again, the group file. Now if you notice, before there was no group assigned to that particular group, right? But now EC2 user is a part of this Docker group. So EC2 user gets all the accessibility of the Docker command, Docker client, everything which can be accessed by the EC2 user, because we added the EC2 user to the Docker group. You can do this, or you can still go ahead and work as a root admin itself. Okay, that's up to you. If you don't want to add the user into the group, then it's up to you. You can just start working with the root itself. But right now I'm exiting out from the root. When I exit, I'll go back to EC2 user. From EC2 user, I'm going to exit because we need to relaunch the session in order to see the reflection of that group to the EC2 user. So right now I'm not into the EC2 instance. Right now I'm on my local machine, Mac operating system. I'm on my local machine, right? So let's step into that EC2 instance again. We'll log in again by creating a new session. What command we need to use is SSH-hi, forward your private key and the username to log into the particular mission. So hit enter. Okay, now we have got logged in successfully. So right now I'm on EC2 user. I'm trying to use the Docker command, Docker - version, sitting from the EC2 user itself. It's working fine. Great. Now with the Docker tool, I wanted to see the list of images. Okay, I'll talk about more in detail about images. Okay, but just I want to list out all the images available in this particular local repository of the Docker. Okay, let's go ahead and see Docker images. The command is Docker images, right? So now you can notice that there is a problem in using this option, the command Docker tool. The command images is not able to manipulate because the Docker daemon is not running. Daemon is representing the Docker engine. Docker engine is more like a server, Docker server, right? So Docker engine is not running. Freshly we have installed, right? So Docker engine is still not up and running. So we need to make sure that the Docker engine is running before you start using the client tool. So how do we do that? So first thing is, let's go. Everyone is waiting. So we'll just step into the status of the Docker. Okay, so we need to check the status of the Docker. So we have systemctl tool for that, system control tool. In the system control tool, you can check the status of the Docker. But I cannot use this command just like that because right now I'm on the EC2 user. It, I mean, since it's more of a system control, it's always good to use sudo command. Okay, sudo and followed with systemctl status and Docker. But anyways, we have already added the group for the Docker, so I guess it's applicable to use this right now to check the status of it. So what does the status says? It's dead. Docker engine is dead. It's inactive. Docker engine is not up and running. So what is the Docker engine? Docker engine is this one. This one, the green one, right? The Docker engine. We need to start the Docker engine. Only then you'll be able to interact with that engine through the Docker client. So that is what is not happening right now because it's dead. So we need to start the Docker. So in order to start the Docker, let's say systemctl start Docker. Let's see if this can be started without sudo. That's a problem. So this is having a privilege issue because we are trying to start. So it's better to give sudo privilege. Now, by now, this command is executed, starting the Docker would have happened. So we are using sudo is for giving admin rights. Sudo means we are giving admin rights to the user, okay, who is not an admin actually. Okay, so now let's go for checking the status again. For status check, I guess there's no need for a admin privilege. Now you can see the status of the Docker is up and running. The engine, Docker engine is running, active. Before it was inactive, it was dead. But right now it's up and running. And the log status is also reflected here. You can read the logs of what is the status of the Docker engine is. Okay, Docker application container engine. Right. So this is what we have here in this procedure of Docker start. So we have a start, we have a status check. Let's see if I can go ahead and stop the container. Again, it's failed. So let's go for sudo stopping Docker services. Now you go ahead and check the status. Now you can see it's dead again, right? Why it's dead? Because we have stopped the Docker, right? So by this way, we are making sure that the Docker is stopped. So again, you can go ahead and start. Check the status. Now it is again up and running. So what are the commands that we are playing around with in order to start the Docker? You need to use the systemctl control tool to start the service, Docker service, start the service, stop the service, check the status of the service as well. But if relatively, if you're running with non-root user, then better you furnish with sudo command so that you will gain the admin privilege. And with that, you'll be able to do whatever operations you wanted to do. But I'm not using Docker straight away. I'm using systemctl. That's why we need sudo. But Docker usage you don't require actually. So let's see Docker images. Now you can see we are able to use the Docker client now. When I say Docker images, there is no images being listed here. How many images we have here is 0 image. We don't have image at all. So we need to pull the image. So from where we need to pull the image? From the Docker Hub. We have Docker Hub, like we have a GitHub, right? GitHub is for source code management repository, right? The same way here, it's a image repository. Container image repository is what is your Docker Hub is. We do have AWS ECR, okay, ECR. So what is that ECR is? Elastic Container Registry, Elastic Container Registry, which is same as like Docker Hub. Okay, but this is something different. The AWS ECR is different and Docker Hub is different, but they both fall under the same segment of container repositories. Container repositories. That is a meaning. Okay, so now let's uh, get into that part. But before that, right now the images are empty. I just wanted to explain what images are. This diagram can help you to understand this. Before that, if you have any questions of whatever, I mean, the command usage that we have used so far, you can just ask me if you have any questions. Any questions you have, please do let me know.
Sir, you told for AWS free tier creation, right?
Yes.
For that, do we need to provide the credit card detail must?
Yes. You have to, you need not provide your credit card. If you have debit card, you can use it. Okay, no requirement of credit card. Debit card, let's say you are using some debit card where you will not use the debit card more frequently. You will have some less balance out there. Then you can use that debit card. Okay. So what happens is they will incur some charge 1 or 2 rupees out of it initially, and then they will credit it back. They will debit 2 rupees and then they will credit to confirm that the debit card is active. Okay.
Okay.
So that debit card will be furnished because they need some guarantee, right? You might be using it under free tier, but unfortunately you have consumed too much of service. Then how do they recover the money? But still, even though if you have used, okay, even though if you have used with more services and the cost is more, you can go for waive off. Okay, but there are limitations for the waive off. One time or two times they will accept, I guess. I have seen 1 or 2 scenarios out of it, but almost 80% of waive off they will do. So let's say, for example, you have consumed some 2000 rupees of services. Okay, so 80% they can waive off for one time or two time. But recurrently, if you are doing it, then obviously they will not support. But ideally, you can use debit card instead of credit card. I use my debit card only to sign up to AWS account.
For while creating, we provide debit card detail, right? For 1 year, it will be free tier mode only, right? For after 1 year, we have to change the mail ID and we'll create one more new account in AWS.
Correct. Yes. If you want one more free tier, then probably yes, of course. That account you cannot use because that account ends with your free tier usage. And moreover, you need to close your account.
Okay.
Close the previous account and then start another new account. If you forget to close, if you don't have any services, it's fine. But if you forget to close and if some of the services are still running, then probably you'll be charged. So once that 1 year is over, you better go and completely close your account.
Okay.
And then later you can have a new email ID and you can use the same debit card. They will accept the same debit card, same mobile number you can use, but email ID should be different.
Okay. Okay. Thank you, sir.
Yeah. Okay. So any other questions you have on this? Please do let me know. Okay. So this is something that you have to have a look at it. So as I told you, right, we'll be having a registry. This is your Docker Hub registry where all the predefined images will be there. We will be calling it as a two images. One is base image. So you can download the base image. Okay. And you can put your application into that base image. Or you want to build a custom image, your own image. I guess we will not find more time today. We'll take it up the part 2 tomorrow, the next week, Saturday as well. So custom image. Custom image is something we build the custom image and we can publish it into our repository. Okay, so you can create an account on Docker Hub. You can create your own image and push that image into the Docker Hub repository, and then you can pull it back from there. But that custom image can be built only on top of the base image. Okay, base image will technically have another dependency with another image also, but for us it's going to be a base image. So let's say this is an Ubuntu base image. So what that Ubuntu base image is, that image is going to carry a lightweighted Ubuntu operating system and all the software dependencies of that particular operating system. It's pre-built. You just pull that image and you're done. You're ready to spin up an Ubuntu server. a lightweighted Ubuntu server. You pull an Redis, okay, Redis image. It will download with the operating system, and then on top of it, the Redis software got installed, and you can make use of the Redis database, right? So you'll be using the Redis for key value pair implementations, right? So you can use that effectively just by pulling that image. It's readily available. Everything is readily available. If you want an Nginx server, you have the image for it. You just pull that image. So images are nothing but collection of multiple binaries, dependencies, and also the operating system. Everything is going to be packaged. It's a package. Images are nothing but a package. What a package contains everything in it. So in terms of image, what it will contain is it will contain the base lightweighted operating system, and it will have the relevant software. So if it is a Redis image, it will have the Redis software as well. If you go for a MySQL image, what it does is it will download that image, have that operating system. On top of that, MySQL database is already there. You're getting it. So there are private images and public images. Most frequently we'll be using only the public images. We cannot use private images. Private images will need an authentication. I'll just explain you how to push an image from our local machine to the registry, okay, Docker Hub, right? And then how to pull them back, right? So we will be creating our own custom image with a file called Docker file. There is a file called Docker file. It's a it's a file which is used for creating a custom image. Okay, you can build a custom image by using the Docker file. We'll get into that probably later. Right now, you just understand the images are nothing but the collection of all the relevant dependencies and operating systems will all be there. On top of that image, only you will launch a container. So containers are what? What are containers? Containers are nothing but running instance, lively running instance of an image, Docker image, container image. So containers are nothing but a live running instance of an image. So from one image, you can launch one container. The container is up and running. So through the Docker client, you'll be able to communicate with this container as well, right? And you'll be having all your application deployed in this container, and your application is up and running in that container, which is which is uh, which is evolved on top of the image. So the end user can access the application giving a request to the running instance of the container. User can't give a request. End user can't give a request to the image. Images are not running instances. From an image, we will bring up a container. So how many instances of container we can launch of the same image? I have one image. How many live instance of containers we can bring? N number of instances. So that's the power of Docker. Just like that, you can spin up one instance of the container from the particular image. If you want one more container running under a different port, you can do so by using the same image. You're getting it. So more convenient. So you need to have more knowledge on the difference between container and image. Image is the base for container. To spin up a container, you need to have image. Through image only, you'll be able to bring a running instance. The running instance is not the running instance of an image is nothing but a container. You can stop the container, you can start the container, right? When you stop, that's all. No running instances. The image is just a static image. It's just a static image. To bring up into a dynamic environment is where we bring up the term called container. The containers are nothing but the running instance of an image. Okay, so there are commands that we'll be using from the client. This is Docker client, this is Docker host, and this is your registry. Through the client only, we'll be able to operate on top of the Docker. Docker host will contain the daemon, the Docker engine. I told you, right? Docker engine, which is nothing but a daemon. The daemon will have the support to create images and spin up a container. So as a client, Docker client will be able to communicate only to whom? To the daemon. Daemon will help us in doing all these jobs. So if you want to run a container, you just say Docker run, then the daemon will get that command, and then based on the command, it will spin up one container on top of the image that you specify here. Right. So Docker client, Docker host, and Docker registry. Registry is something, a web registry, where you'll be having it in a separate cloud space or somewhere where you'll be seeing all the images are available there. Is this clear? Is this diagram understandable? So what the Docker client provides is Docker client provides a way to communicate to the Docker daemon through commands, multiple commands. So Docker is a client tool, Docker client tool communicates with the Docker server, Docker engine in order to perform the creation of images, pulling of images, and then creating a container out of it, stopping the container, removing an image, removing a container, all these operations which we can do only through the Docker client. When you install the Docker software, these are the things which is installed, not the registry. Registry is separate thing, right? So these tools are already got installed into the machine. Is this clear? There are more theories out there, but I don't want to take you to more of a theory, but at least this base is something very important to start with, right? So that's why I'm just spending some time here. So if you have any questions on this understanding, please do let me know. Any questions? The reason for having live session is to take your questions, okay? Otherwise, anyways, the recording is going to be there, so I'm going to give you the recording. It's going to be posted onto my YouTube channel, so you can take it from there. But the idea of this live session is to interact. So if you have any questions, please do ask me. Let me try to answer you at my best. Okay. If in case there are no questions, I guess so. Sure. Okay. So the session got expired, so we need to log in again to our EC2 instance. Okay. So Docker systemctl status of Docker, which is up and running. Great. So now listen carefully. I'm going to use the Docker client tool to pull an image. Right now we don't have image, right? We can also use Docker PS. PS means process. Process of whom? Image. Process means what? It's a running instance, correct? Process is generally we call it as a running instance. So running instance of an image can be listed by using PS. Means the running instance is technically called as what? Running instance of an image is called as dash. Is nothing but container. Containers are nothing but running instance of an image. Image is also not there. When the image itself is not there in my local Docker repository, then obviously your containers are also not there. Look at this. This is image ID. Now, if you look at it here, it's a container ID. Is there any list of containers? No. Is there any list of images? No. If there is no image, then there is no container. You might have one image and you can have one container, but not necessarily that container should be created. You can only have the static image in your place. Whenever needed, you can spin up a container, and if needed, you can stop the container or even you can remove the container. So we'll see those things shortly. But right now, first we need to pull an image. So what is a command to pull an image? Pull, Docker pull. What is the image that you want to pull? Is Tomcat image. Tomcat server. The version exclusively I'm looking out for 9.0. Okay, Docker pull Tomcat 9.0. This 9.0 refers to the version of the Tomcat. Technically, in Docker perspective, they will call this as an tags. This is called as a tag. Okay, this is your repository name. Repository name. From this repository, this particular tag is nothing but version. This particular version, you're trying to pull it into your local machine. That is in the EC2 user machine. You're trying to pull it. What is this called as? This is the image, container image, right? But from where it will get downloaded? That's a question. So let's go to the Docker Hub. So hub.docker.com. So you can register. Okay, you have a free access. You can register. I guess you can create one private repository and n number of public repository. Okay, so you can just sign in. You also have commercial thing. But I'm using only the free tier. So it's hub.docker.com. Okay, probably have heard about this. If not, just have a look at it. So you can see I've already have one private image. I have created one private image 4 days ago. Okay, one pull have happened. Okay, is there any star? No. And typically it's like creating a repository. Okay, through UI of this web application, you will be able to do it. So, but if you see, there are many repositories are there. So if we go to the if you go to the explore option, you'll be able to see multiple branded images are there. So you want MySQL, you go and get a MySQL version. Nginx is there, Alpine is there, OpenJDK, where this will have the image with Java software. How many downloads? 1 billion downloads have happened, right? So Redis, just now I told you, this is like in Twitter, we'll be having that blue tick, right? That says that it's an official account of that particular celebrity, right? The same way here, this is the reference for understanding that it is an official that is accredited by Docker community. So here you have node image, MySQL image. So in just a span of 2 minutes, you'll be able to launch a MySQL database. And that server can be acted as a MySQL server. So your application can communicate to the server, MySQL server, and you can do your CRUD operation on top of that relational database. Right. So like which there are multiple images are there. Okay. These many images are there, and Postgre database is there. Okay. You also have Ubuntu. See Ubuntu, right? It's a Debian based Linux operating system based on free software. So this is what the repository for container images. So you can search for Tomcat. And you also have an official image for Tomcat. Tomcat is a repository name, as I said, and you'll be having a tags. In the tags, you need to look out for the version that you wanted. Which version you wanted, you can just look out for it. So right now, let's explore this Tomcat. So I don't need to you can't download from here. Okay, it's only through Docker pull. Okay, Docker pull command and the repository that you wanted and the tag versioning 9.0. Hit enter. Okay, there is a session expiration happens. So if you can't follow me, please do ask questions. Okay, stop me there because it's virtual, right? So I cannot understand your facial expression and I cannot proceed accordingly since more virtual. So if in case you have any questions, please do ask me. Anyways, let's extend this training probably next week as well. So Saturday will be a part 2. Let's take this as a part 1. We'll take up a part 2. So we'll have more space to learn this concept more in detail. Let's get into the immersed learning of Docker. Okay, so Docker pull Tomcat 9.0. Hit enter. Now you can see it's all the way downloading from Docker Hub. Okay. Okay, it's downloading from Docker Hub. Why it didn't ask for authentication? Just now I logged into the Docker Hub, right? Why it was not asking for the authentication? Because these images are public image. For public image, no need of credentials, no need of authentication credentials. Okay, it's like public GitHub repository, right? You also have private repository there, right? So when it is a private, then we need to talk about authentication. We will have a study on that next week, probably we'll be discussing it. So right now you can see pull is complete. Now, if you look at when you download an image, when you pull an image, the images will be pulled as layers. These are called as layers. I guess 10 layers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 layers. So how the images are made up of? Images are made up of layers, layer by layer. In this layer, there will be one layer which will have an operating system, lightweighted Linux operating system. Okay, so now if you go back to this source, this is what your images are. Hope it's visible, right? So if you see what an image comprises, image will comprises a layer by layer, a piece of uh, layers, a piece of layers. So the layer will be like you're having an UUID. All rights and delegates go in this layer only. Okay, these are called as image layers, where you will have read only operations. Okay, read only operations. You can also do some write. If in case you want to do some write, then it is going to be a container. On top of the container only, you'll be able to having the write privilege. But you cannot you cannot write directly onto the operating system level. So let's say this is an Ubuntu. So inside the Ubuntu operating system, you cannot do it. Above this image, there will be a container layer, and that container layer only you can perform the write operations, but not directly into the images layers. Okay, so it's saying the size of each and every layer. Okay, which layer is going to have what, we don't know, because that's all more of a binary version, right? So imagine that your layers are nothing but I'm sorry, your images are made up of collection of layers. Okay, uh, technically we need to go more deep into it only when we get into the administrative operations in the Docker. At the time we need to learn more about it, but right now this is not required since we are getting into the fundamental. Just imagine that images are nothing but layers. Okay, so now if I go and download again, pull Tomcat, what happened? Pulling from the library, but it was quick. Why? Because already it got downloaded. The image got downloaded already. So it will not go and download again. It will first check in the local repository. In the local repository, if that particular tagged repository is already there, it will never download that image. Okay, so that's another advantage here, right? And, so your bandwidth can be saved. So if you go and check Docker images, now you notice that there is one image Tomcat version of 9.0. This is your image ID, and this is something which got updated 10 days ago. And the size of this image is 685 MB. 685 MB is something okay, right? We have an operating system in it, lightweighted operating system. You can do all things, whatever you do in general Linux operating system can be done on it. But you will be getting only CLI access. There's no GUI access. If it is GUI, then you need to rely only on virtual machines. Docker, you can only rely on CLI. Okay, not GUI. So in this case, we have an image, but let's see if we have the instance running out of this image. Is there any instance? A container is running. We need to check with PS process. So Docker PS, ideally no containers. No containers are there. Means we haven't spinned up any container out of this image. That is the meaning, right? So what we have to do, what is the containers are? Running instance of an image, running instance of an image. I'm recalling this again and again because you should remember this. Okay, so running instance of an image is what we call it as container, but right now we haven't spinned up any running instance of an image, so technically there is no container available. So how do we run this image? How do we spin up a container out of this image? Docker run. Docker run. Okay. -d. -d denotes detached mode. Okay, detached mode. Run this container in a detached mode, means in the background, and make us to come back to the prompt. Okay, after running the container, it will take you back to this prompt. Otherwise, it will not take you back to the prompt. I'll just show you this. If I don't give -d, okay, then see, without -d, I'm just giving -p, which is for port mapping. Okay, this is a Tomcat, right? So Tomcat default port is 8080 colon 8080. So what we do with this -p is, it is called as port mapping. Port mapping. Please understand this. This is very important. Generally, Tomcat will run an 8080 server, run on 8080 server port number, right? The Tomcat server will run on 8080 port. So this is your container container service port. That is Tomcat port. Okay, container port. When a user wants to hit the request to this Tomcat, when a user wants to request this Tomcat, how can they reach this Tomcat? They have to reach this EC2 instance, right? Who's your EC2 instance? EC2 instance is nothing but your host, correct? EC2 instance is your host operating system. First, you need to reach your host operating system, and then only you can reach your container, because containers are running on top of the host operating system. If you look back the diagram clearly states that you have a host operating system here, right? So when a user wants to access the application running in a Tomcat application, they can't directly go to the container. They have to request whom first? They have to request the host, and through the host will redirect to the specific container where you want it. So when you request, you need to do a mapping. 8080 is the port in which the Tomcat server is running with the application, and colon 8080 what I gave is what I'm giving is, when a user requests with 8080, it will hit the host operating system, and whenever user comes with the 8080 request, immediately that will be redirected to the 8080 port of the container level. So this is your host port, host mission port, mapped to container port. Please understand. Okay, host mission port is mapped to container port. Okay, so that's why we tend to do this port mapping here. You're getting it. So once the port mapping is done, then you can define a name for your container, hyphen name, the container name you can give. So let's say Tomcat container followed with, on top of which you want to generate a container. You want to generate a container on top of the image, right? On top of the image, you want to generate a container. So in that case, you have to provide the image ID. You have to provide the image ID here. So Docker is a client tool. Run is a command. To whom this command will be given? Docker client tool will give this command run to the daemon. Who's your daemon? Is the Docker engine. Docker engine will help us in picking this image and create a container, do a port mapping, and ensure the container is up and running. Those are done by your Docker engine. This one, daemon, the Docker engine, right? So we are issuing which command now? Docker run. So Docker run meaning is run a container out of an image. Now which image we have in the images repository of the local machine? Tomcat image. The Tomcat image is going to be used for spinning up one container out of it, which is a running instance of that particular image. Is that clear? So let's go back. Now you need to get this ID. Sorry. The image ID. Okay, with this you hit enter. Now I'm not using -d. Please notice I'm not using -d. If I'm not using -d, what will happen? Let's see. So container is all the background process is visible for us. Whatever is happening is getting displayed in the log, and you will be able to see the log informations. Okay. Now you can see that it is starting the Tomcat. Tomcat got started. And it's going to run in which port? HTTP 8080, and the mapping is also done for us. But if you notice, we are unable to come out of this shell. Okay. Why? Because it is not running in background. It is running in foreground. It is running in foreground. If you use a detached mode, the host prompt will be detached and it will be running in the background, right? So that's what which we need to do. So in order to perform that, I'm just using Control C. Okay. So Docker PS. Now there is no container. If you say -a, actually see there is one container. In Docker PS, there's no container, but Docker PS -a is able to show there is a container. What is the difference? Docker PS will show all the running containers. Docker PS command alone will show running containers. But the container which is stopped, okay, means you can see the status of the container is exited, right? Why it got exited? Because I gave Control C. It was running in the foreground, right? I gave Control C, means it shut down that container there. So that's why you should always run the container on a detached mode to be on a interactive mode with the prompt back again. Okay, so let's spin up this. Anyways, I just remove this again. You can also learn the Docker RM and the container ID. So RM is remove. Remove what? Remove the container. Only the stopped container can be removed. Great, the container got removed. Now you trigger the command docker ps -a. There's no container available in the stopped mode, and there is no container available in running mode. Okay, so docker ps is for showing all the list of containers that are running. Docker ps -a, all. -a means all. Show all the containers, even including the container which got stopped. So now we need to bring back that docker run command. This time I'm going to issue with an option called -d. Okay, -d. -d means detached mode. Now you see nothing is shown in the background. It just keeps running in the background. The ID is alone shown. Then we are back to the prompt. We are back to our prompt. Right? We came back to our prompt. So let's see if this container is running or not. How do we see the container is running or not? The command is docker ps. Great. The command is up and running. The Docker container is up and running. On top of which the container got spinned up on top of the specific image. That image ID is also listed here. This is your container ID. This is your image ID. And when the container is launched, what command that need to be used while the container is getting launched? It is saying you start the Catalina.shell script. This will help us in starting the Tomcat server. Right? This command will be used to start the Tomcat server. This is a initial command that will be executed on top of running the container. The same way, while we are creating our own custom image, we can also give all these commands, startup commands. These are called as startup commands. Use the startup commands to start some services at the time of launching the container itself. Okay. Now the port mapping is also done here. You can see that there is a port mapping, right? So we are also done with the specific port mapping. Now we need to access this Tomcat. How do we access this Tomcat? Let's go to our EC2 instance, capture this DNS IP. Okay, or you can just use the IP alone. What is the port I need to issue for the host? Host mission, that is EC2 instance mission. I'm reaching the EC2 instance server port, which is 8080. And when I reach to that 8080, I'll be redirected to the 8080 of the container Tomcat port, and it will help us in giving the response. But unfortunately, we will not get the response now. I'll just take another 5 more minutes. Sorry for taking more time. Just wait for a few more seconds to see what's the response of this request. So I'm hitting the request to the EC2 instance. So it's trying to send a request multiple times. The reason why the response is not coming, I'll just tell you. The port which we are trying to access here, okay, the port which we are trying to access here to that EC2 instance is not open. This port is not open. The default port that is open is 2222. That is SSH port. Only you can connect to the server through SSH protocol with the port of 2222. But now you are using HTTP port. You didn't give the privilege in the EC2 instance settings that the 8080 port have to be open and it should be kept accessible by anyone outside the instance, outside uh, the network of the EC2 instance, right? So now it's unable to reach. So just go back and uh, do a little bit of fine tuning on the settings. So we have something called security here. On the security, you have a security group. Just clicking on the security group, it'll redirect to edit our inbound rules. So already there is one inbound rule for SSH 2222 port. You can click on edit inbound, incoming request, right? It's an incoming to EC2. So when it is incoming to EC2, through what port you are incoming? 8080. That 8080 should be acceptable by this EC2 instance. So you can add a rule, custom TCP with 8080. Who can access? Anyone can access this port. Okay, by giving the settings, you just save the rule. Instantly, it will be reflected on the EC2 instance. Now you just go back and give a request. You'll be seeing the default homepage of a Tomcat. It should be. It's actually reaching, but it is looking out for the resource. Okay, but we don't have any resource in the Tomcat, right? The reason we don't have any resource is because that folder is empty. Web apps folder is empty. I'll just do a little bit of settings. So what we have to do here is we have to shift to this we have to get into the container. Okay, I'll tell you how to get into the container. Just another 2 to 3 more minutes. It's good. Actually, 8080 is now acceptable, but Tomcat could not respond anything. Tomcat is unable to give you some response. It doesn't have any resource in it. That's why 404 error. But practically, we are reaching the EC2 instance now globally. You can also access. I will share this. Similar thing I did last week also, right? So I'll share this link. You can try to give access to this Tomcat. For that only, I'm trying to connect. So I'll just take another 2 more minutes. So I need to step into the container. How to get into the container and see the operating system of that particular container. Right now we are on the EC2 instance operating system, right? So Docker PS, already the container is running. So Docker execute in an interactive mode, IT in an interactive mode with the container. So what is a container that we have there is the name of the container you can give. What is the name of the container? We have Tomcat container, Tomcat-container. Okay, and you need to log into the shell. So bash shell of that operating system, which is running inside the container. So you hit enter. See, directly you have been taken into the bash shell, which is redirected to the Tomcat directory. Now notice that I'm in the root, directly in the container's root. But here what you have is EC2 user. So I'm now inside the container operating system, lightweighted operating system, Linux operating system, and logged in directly as a root user. This is EC2 instance host machine user. See the difference. This is not my EC2 instance root. It's containers root user, which is a Linux operating system inside the user local Tomcat directory we are in. Okay. If you just go ahead and do some directory check, we have web apps dist. If you notice, you have something called web apps directory where technically we place all our applications, right? The artifact. Inside that, there is nothing actually. That's why we are getting this 404 response. So what we have to do right now is there will be files available in webapps.dist. cd webapps.dist. Inside this, you can see a lot of files, root, docs, examples, host manager. So we can copy this recursively. Recursively means even the subdirectories of these directories will be copied. Copy the recursively dot slash star means copy all. Copy all from this current directory. Copy all the directories, subdirectories, files, everything from this current directory, web apps dist, and paste it where? Paste it into the web apps directory. This is web apps dist folder. You need to copy everything from the web apps dist to web apps. So you can say slash user slash local slash tomcat slash web apps. That's the actual working directory, right? That we can see for the web apps. Now it got copied. Now you get into the web apps. Now you will have something that is nothing but the dist files and folders. Now let's go back and give a request. Beautiful. Now you can see the home page of the Tomcat. Home page of the Tomcat, right? Before we were not getting because web apps folder was empty. Now you are learning how to step into the container, inside the container, and I'm going to investigate all the directories. Container has a lightweighted operating system in it, right? I'm touching the container right now by using the specified command of the tool Docker client exec execute interactive mode with the container in the specific bash shell directory. Now you can give a try at your end and see if you are able to access this from your system. So just look at the chat box. I'm just sharing this link just to gain some feel of whatever we have learned, right? So just a understanding of it. So it's been shared. You can just click on that and see if you are able to access this Tomcat home dashboard. Actually, this is not what we need to. We need to take the application, our sports application, and deploy it inside the Tomcat, and we need to access that application's response that we will see next week with more advanced commands of the Docker as well. Okay, it's
Yeah,
quite
okay, sir.
interesting. It's accessible.
Yeah, it's accessible, sir.
Oh, great, great. Yeah. So others can also try. I guess Ravindra was able to access good. So that's how it is. So Dockers are pretty good to work with and must skill that we should possess. If you're a developer, doesn't matter that we need to do only the developing job. We should also have knowledge on infrastructure environment. So Docker is one essential skill that nowadays people are looking out from the market. So it's like a full stack developer means we should also have some knowledge on the DevOps. So in that case, we need to have some knowledge on Docker because you will be building your own Docker file, creating an image, instructing the DevOps team to work on that particular Docker file to make sure the artifacts are created out of it, right? So Dockerizing means containerizing. These are some of the buzz terms that we will be using. Dockerizing. Dockerizing means containerizing. Containerizing means an application is getting into the container. So whenever needed, we can spin up the container. We don't need to do anything else other than that. So if I want to ship it, what I will ship? If I want to ship to someone else, so let's say I want to give it to you and you want to run, you only need the Docker environment in your specific production server or staging server or QA server. The thing, okay, let me get out of this. So the thing that is required to be shared with you is only the image. You don't need to put it in the Docker hub. Okay, you can create one custom image, okay, and push that custom image into some of your private repository. Your organization might have a container repository, private container repository. There you can push it and you can pull it from there. But the commands that you have to use is push and pull. Push the image, pull the image, run the container. Push the image, pull the image, run the container. Containers are nothing but the running instance of an image. Images carries everything. Okay. And on top of this image, now what we are going to do is we are going to uh, push the artifact. Which artifact? The WAR, web archive. When we push the artifact in the web archive, where we need to push the web archive? Inside the web apps directory. Just now we saw that, right? If you copy that WAR file and put it in the web apps of this container, then your application is up and running. So you can just give a request to the application, get the response from the application itself. Is this clear? So I'll just stop here. I guess I've taken 10 more minutes additionally. So if in case you have any questions, please do let me know. I'm ready to answer for your question. So this will be uploaded into my YouTube channel, and I'll be sharing it on the group, the channel, Telegram channel. So one thing that I wanted you people is try to make the channel reachable to many people. The intention of my sessions are not commercial, so I'm just doing it on a free time. Okay, completely on my free time, I'm just doing it. So I cannot, because I'm completely loaded with my official work on weekends. I'm sorry, on weekdays. So this is out of my interest. I'm just wanted to share my knowledge with you people. So you can take that channel visible to many of your friends who wanted to be connected with us, so that we can technically get interacted, and we can learn a lot of things with each of us who's having a different knowledge. So that's the main intention. 100%, this is not a commercial, and I'm not coming up with any commercial commitments of any trainings. Okay, so I just want to share my knowledge, whatever I have in my 15 plus years of experience. Okay. um, so any questions, please do let me know. Otherwise, we can close the call. I'll just stop the recording.